In the last episode, we talked about the search for Dyson spheres, hypothetical megastructures that advanced civilizations could build around stars to capture all their energy. We saw that a recent study by Uppsala University in Sweden identified 7 candidate stars that emit more infrared radiation than expected, which could indicate the presence of these colossal structures. But before we go around announcing the discovery of superdeveloped ETs, let's take it easy. As the study project Hephaestus 2 Dyson sphere candidates from Gaia DR3, 2 mass and WISE, published in 2024 by Matthias Suazo, Eric Zackerson and their colleagues makes it clear it is essentially impossible to prove the existence of Dyson spheres based on photometric data alone. In other words, infrared radiation, although intriguing, is not definitive proof of the existence of Dyson spheres. There are other plausible explanations, such as the presence of dust disks around stars. In fact, the study by Suazo and his colleagues focused on partial Dyson spheres, which would cover only part of the star, a concept that resembles models of dust disks. And what makes these 7 candidates even more interesting? They are all red dwarfs, a type of star smaller and cooler than our sun. The rarity of dust disks around red dwarfs is one of the points that caught the researchers' attention. But if they aren't Dyson spheres, what could be causing this excess infrared radiation? One possibility is debris disks, made up of dust and rock fragments orbiting the star. These disks are common in young stars, but the analysis of the optical variability of the candidates suggests that they are not so young. And to rule out other sources of error, such as contamination by galactic dust or overlapping images of distant galaxies, the study used various filters and analyses, including an artificial intelligence algorithm to identify images of nebulae. Despite all these precautions, the possibility of chance alignments with distant objects cannot be completely ruled out. Analysis of the displacement between the positions of the stars at different wavelengths, W1, W2, and W3, indicated that 6 of the 7 candidates did not show significant deviations, but one of them, candidate G, showed a greater displacement than expected. At the end of the day, the big question remains, what is the true nature of these 7 mysterious red dwarfs? Unusual dust disks, partial Dyson spheres, or something else entirely? The study by Suazo and his colleagues is just the first step in an investigation that promises to be long and fascinating. Spectroscopy, the technique that analyzes starlight in detail, will be crucial to unraveling this enigma. Analyzing the spectrum of the light emitted by these stars will make it possible to determine the temperature, composition, and movement of the material around them, helping to identify the presence of dust disks, Dyson spheres, or other phenomena. Can you imagine a civilization so advanced that it would be able to build a gigantic structure around a star to capture all its energy? Sounds like science fiction, right? But this idea, proposed by physicist Freeman Dyson in the 1960s, is being taken seriously by scientists looking for signs of intelligent life outside Earth. These hypothetical structures, known as Dyson spheres, would be the holy grail of space engineering, an undeniable sign of a civilization much more advanced than ours. But how do you find something so colossal in space? The answer lies in infrared radiation. A Dyson sphere, absorbing the star's light, would heat up and emit infrared radiation, a type of heat that our telescopes can detect. It's like looking for a fire in the middle of the night, only on a cosmic scale. A recent study, published in 2024 by Matthias Suazo and his colleagues at Uppsala University in Sweden, did just that. It scoured data from telescopes in search of stars emitting more infrared radiation than expected. The article is called Project Hephaestus and 2 Dyson sphere candidates from Gaia DR3, 2 mass and WISE, and used data from 3 large telescopes. Gaia, 2 mass and WISE, the researchers developed a system, a sort of sieve, to analyze the light from millions of stars and identify those with an excess of infrared radiation. To make sure they weren't being fooled by other phenomena, such as stardust or young stars, they used various filters. One of them even uses artificial intelligence to analyze the images from the telescopes. It's cutting-edge technology helping in the search for ETs. And what did they find? 7 candidates, 7 stars that emit more infrared radiation than they should, and all of them are red dwarfs, a type of star smaller and colder than our sun. But before you start celebrating the discovery of alien megastructures, scientists warn that more studies are needed. As the authors of the study themselves mention, It is essentially impossible to prove the existence of Dyson spheres based on photometric data alone. In other words, you can't be sure from starlight alone. There are other astrophysical phenomena that can generate this excess infrared radiation, such as dust disks around stars, for example. But the fact that they found 7 candidates, all red dwarfs, is already an intriguing result. And the conclusion of the study is clear. We need to investigate these stars further. Observations with more powerful telescopes, capable of analyzing the light from these stars in more detail, are essential to determine whether the excess infrared radiation is really caused by alien megastructures or by other natural phenomena. So, have we finally found evidence of advanced civilizations building Dyson spheres around stars? It's too early to say, but the search continues. Science advances every day, and who knows? Maybe soon we'll have the answer to this question that has been with us for so long. In recent episodes, we've explored the search for Dyson spheres, hypothetical megastructures that advanced civilizations could build around stars to capture all their energy. We followed the study by Uppsala University in Sweden, which identified 7 candidates for stars with excess infrared radiation, a possible signature of these colossal structures. But as the authors of the study, Project Hephaestus 2, Dyson sphere candidates from Gaia DR3, Tumas and Wise, Suazo et al., 2024, warn us. It is essentially impossible to prove the existence of Dyson spheres on the basis of photometric data alone. Infrared radiation, although intriguing, needs to be investigated with caution. And spectroscopy has emerged as the crucial tool to unravel this mystery. By analyzing the light from these stars in detail, we will be able to determine the temperature, composition, and movement of the material around them. If the excess radiation is caused by dust disks, for example, spectroscopy will reveal the characteristic signature of the minerals and gases present in these disks. But what if spectroscopy confirms that the infrared emission is not coming from stardust? Then the Dyson spheres hypothesis gains strength. The study by Suazo and his colleagues used a model that simulates how the light from a star would be modified by the presence of a partial Dyson sphere. Spectroscopy can tell us whether the infrared emission observed in the 7 candidates is consistent with this model. What's more, spectroscopy can help us determine the spectral type of these stars more precisely. The study classified them as red dwarfs based on their photometric parameters, but spectroscopy can reveal important details about their temperature, surface gravity, and chemical composition, confirming or refuting this classification. In addition, spectral analysis of the region around the H-alpha line will be key to determining whether these stars are in an early stage of formation, which would explain the presence of dust disks. H-alpha emission is an indicator of the presence of ionized hydrogen, which is common in star-forming regions. Spectroscopy will also allow the application of gyrochronology, a technique that estimates the age of a star based on its rotation. Younger stars rotate faster than older stars. If gyrochronology indicates that the candidates are young, the dust disk hypothesis is strengthened. In short, spectroscopy is a powerful ally in the search for the true nature of the 7 mysterious red dwarfs. Through detailed analysis of the light from these stars, we will be able to confirm or rule out the presence of Dyson spheres, dust disks, or other astrophysical phenomena. But regardless of the final answer, one thing is certain. The search for signs of extraterrestrial life continues, and each new study brings us one step closer to solving this enigma that has fascinated us for millennia. What if spectroscopy shows us something completely new, something we've never seen before? Then, folks, we'd have a revolutionary discovery. The possibility of finding something totally unexpected is what makes science so exciting. It's worth remembering that the study by Suazo and his colleagues focused on partial Dyson spheres, which would only cover part of the star. But what would the spectral signatures of a complete Dyson sphere, encompassing the entire star, look like? This is a question that has intrigued scientists and fueled the imagination of science fiction writers for decades. A complete Dyson sphere would absorb almost all of the star's visible light, making it practically invisible to our optical telescopes. However, the infrared radiation emitted by the structure would be intense and detectable. The spectrum of a complete Dyson sphere would probably resemble that of a black object, an ideal body that absorbs all the radiation that falls on it and emits radiation at all wavelengths, depending only on its temperature. But would this theoretical model correspond to reality? The detection of a complete Dyson sphere would be a historic event, a milestone in the search for extraterrestrial life and undeniable proof of the existence of civilizations much more advanced than ours. But even if spectroscopy rules out the Dyson sphere hypothesis for the 7 candidates, the study by Suazo and his colleagues has already left an important legacy: the discovery of 7 red dwarfs with excess infrared radiation of unknown origin. The study highlights the importance of continuing to investigate these peculiar objects, as they can reveal new astrophysical phenomena and expand our knowledge of the diversity of star systems in the universe. As the authors of the study conclude, although our candidates show properties consistent with partial Dyson spheres, it is definitely premature to assume that the infrared radiation presented in these sources originated from them. Caution is key, but curiosity drives us to unravel the mysteries of the cosmos. And so, with the help of spectroscopy and other research tools, the search for extraterrestrial life and the secrets of the universe continues. The adventure of science is endless, and each new discovery opens doors to a universe of possibilities.